Dear students, in previous class we were discussing about the uniform continuity of a function. We know that a function f from a to 1, where a is a subset of 1, is said to be uniformly continuous on a if for all x comma y following a, modulus of f of x minus f of y strictly less than epsilon, provided modulus of x minus y less than some delta of epsilon, or simply some delta. Okay, so this is the condition for the uniform continuity of a function. Now let us discuss about the criteria for non-uniform continuity of a function. That is an important idea, the criteria for non-uniform continuity. So the non-uniform continuity means f is uniformly continuous if it satisfies this condition. So the function f from a to r, where a is a part of r, is said to be non-uniformly continuous if for all x comma y following a there exists some epsilon positive such that modulus of f of x minus f of y greater than or equals epsilon, provided mod x minus y less than delta. So this is the non-uniform continuity. This is the definition for non-uniform continuity. Means a function is not uniformly continuous, which is not a non-uniform continuously. So this is the criteria, or sorry, this is the condition for the non-uniform for a function. That is a non-uniform continuity for a function. That is f from a to r is said to be non-uniformly continuous if modulus of f of x minus f of y greater than or equals epsilon, provided mod x minus y less than delta. Okay. Now we are going to discuss about the criteria for non-uniform continuity. So there is a result that a is a part of R. A is a part of R. F is a function. F is defined from where to where? F is defined from a to 1. Then the following are equivalent. The following are equivalent. First one, f is not uniformly continuous. F is not uniformly continuous on E. Second one, there exists epsilon not greater than 0 and delta greater than 0. There exists epsilon not greater than 0 and delta greater than 0. Then there are points x delta and u delta, means that is depends upon this delta, such that modulus of x delta minus u delta strictly less than delta, but modulus of f of x delta minus f of u delta greater than or equals epsilon naught. And the third one, for all epsilon is positive, there exist the sequences xn and un. There exist the sequences xn and un in A such that limit xn minus un equals 0, limit xn minus un equals 0, and modulus of f of xn minus f of un greater than or equals epsilon. So our task is to prove these three conditions are equivalent. How to prove this one? One implies two. How to prove one implies two? What is one? Suppose assume 1. Assume 1. That is, f is not uniformly continuous. F is not uniformly continuous on E. So by definition of the non-uniform continuity of a function, we know that there exists some epsilon naught is positive, comma delta positive, such that any two of the points, suppose it may be x delta and u delta fall in A, with a modulus of x delta minus u delta less than delta, then your modulus of f of x delta minus f of u delta greater than or equals some epsilon naught. This is from where? This is by the definition of the non-uniform continuity of the given function f. So clearly 1 implies 2 is immediate. When f is not uniformly continuous, then by the definition of non-uniformity, there exists some epsilon positive, delta positive, and any 2 point x and u fall in A with a modulus of x minus u less than delta, f of x minus f of u greater than or equals epsilon naught. Okay, so 1 implies 2 is immediate. Now 2 implies 3. 2 implies 3. This is immediately from definition. 2 implies 3. What is 2? Suppose 2 hold. If 2 holds. If 2 hold. When 2 hold, 1 implies 2 is immediate. Why? Because this is by definition. Okay. Suppose 2 hold. That is, for all epsilon naught is positive, there exists delta positive with x delta and u delta fall in A, such that mod x delta minus u delta less than delta, but modulus of f of x delta minus f of u delta greater than or equals epsilon naught. This should be held there. How to prove the third one? It is given uxn and un are any two sequences in A, such that limit xn minus un equals 0. Limit xn minus un equals 0 means there exists some delta positive such that modulus of xn minus un strictly less than delta. Okay, if limit xn minus un equals 0, that means there exists some delta is positive with a modulus of xn minus un less than delta. When modulus of xn minus un less than delta, and instead of x delta here it is xn, instead of u delta here it is un. So according to the argument in second, means our second argument, then there exists some epsilon is positive such that modulus of f of xn minus f of un greater than or equals epsilon naught or epsilon. So 2 implies 3 finished. When 2 hold, instead of x delta and u delta, we can choose the 2 of the points or sequences here xn and un with the limit xn minus un equals 0. That means mod xn minus un less than delta. So this hold means 2 implies 3 also finished. Now how to prove 3 implies 1? 3 implies 1. 3 implies 1 when 3 hold. If 3 hold. If 3 hold means for all epsilon is positive with a limit xn minus un equals 0, that is mod xn minus un less than delta and mod f of xn minus f of un greater than or equals epsilon, that is nothing but the definition of non-uniform continuity of the given function f. Hence f is not uniformly continuous on E. So 3 implies 1 is also immediate. Okay, so these are, so hence we can conclude that these 3 conditions are equivalent. Clear? Okay. So now in previous class we already proved that f of x equals 1 by x. F of x equals, we prove an example, that is f of x equals 1 by x, where x fall in set of all x in R with a x greater than 0 is not uniformly continuous. Okay, not uniformly continuous. This is we already proved in previous class. F of x equals x, 1 by x, where x fall in set of all x fall in R with a x greater than 0, which is not uniformly continuous. That is already proved. But by using this criteria, non-uniform criteria, how to prove the non-uniform continuity of this function? That's an interesting case. So consider the third argument. The third statement says that when 3 implies 1, that is, for all epsilon is positive, if xn and un are any two sequences in A with the limit xn minus un equals 0, then mod f of xn minus f of n greater than or equals epsilon. If this hold, means f is not uniformly continuous. For here, let xn equals 1 by u and un equals 1 by n plus 1. Okay, xn equals 1 by n and un equals 1 by n plus 1. So what is the limit n goes to infinity, xn minus un? Limit n goes to infinity, xn minus un equals limit n goes to infinity, 1 by n minus 1 by n plus 1. So which equals, it is n plus 1 minus n by n into n plus 1, surely it is 0. Finally, limit xn minus un equals 0. Okay, so by the non-uniform criteria, now consider modulus of f of xn minus f of un. To prove this is not uniformly continuous, now we have to show that modulus of f of xn minus f of un greater than or equal some epsilon. Okay, but what is f of xn minus f of un? Xn is 1 by n, here f of x is 1 by s, this is a given function. So f of xn, 1 by xn, it is 1 by xn equals 1 by n is n. So it is n minus of n plus 1. F of xn is 1 by n, f of xn is n, f of un is n plus 1. Why? Because f of un is 1 by n, 1 by un, that is 1 by n plus 1, it is n plus 1. Equals n minus n, modulus of minus 1 equals 1, means this is greater than some epsilon naught. So clearly we know that limit n goes to infinity, xn minus un equals 0, and the modulus of f of xn minus f of n greater than epsilon naught. So by this non-uniformity criterion, then the given function f of x equals 1 by x is not uniformly continuous. So this is the proof of the non-uniform continuity of the given function f of x equals 1 by x depends upon this non-uniform criteria. So this is a simple proof. Agreed. So in previous class we already proved that f of x is 1 by x, and that where x fall in this domain is not uniformly continuous by using the definition of uniform continuity of a function. But here we use the non-uniform criteria, and the problem is reduced. So in previous case there is some lengthy problem, but here the problem is so reduced. So you can choose some xn and un in the given domain in this way, and we know that limit xn minus un equals 0, but by using this criterion it should be greater than epsilon naught. So this function is not uniformly continuous. Okay.